In our first example, we have a car and a bus traveling for the same amount of time, but not for the same distance. Because they are traveling for the same amount of time, but not for the same distance, we can expect that their rates are not going to be the same. And we get that in the second sentence, where the rate of the bus is 20 miles per hour slower than the rate of the car. We should consider the time that each vehicle is traveling separately and then make them equal to each other, as we know that they will travel for the same amount of time. So let's begin by considering the car. We know that the car will travel a total of 300 miles. That's the distance that the car is traveling. We don't know the rate of the car, so we'll identify that as x. For the bus, we're going to do a similar fraction where we have 180 in the numerator as the distance traveled by the bus, but we know that the rate of the bus is 20 miles per hour slower than the rate of the car, meaning the bus needs to be x minus 20. Because the two vehicles are traveling for the same amount of time, we know that these two time-based expressions for the car and the bus need to be equal to one another. And in this case, we have 300 over x, is equal to 180 over x minus 20. This is the time of the car, and this is the time of the bus. Because it's a fraction equal to a fraction, we can cross multiply. And we get 180x is equal to 300 times x minus 20. Distributing the right-hand side. Putting the x's all on the left. Don't be alarmed by the fact that we have a negative coefficient that's offset by the negative 6,000. Dividing by negative 120, and we get that x is equal to 50. Because this is such an easy solution to check, it makes sense to go back and make sure that that actually works. We're going to put 50 right here and 50 right there. 300 divided by 50 is equal to 6. 180 divided by 30 is also equal to 6. And we have our bus and our car traveling for the same amount of time. So we wrote separate time statements, separate time rational expressions for the two vehicles, and then set them equal to each other because we know that it took the same amount of time.